Hello and welcome to an introduction to BroadBand-HamNet, the basics for newcomers part 2. If you have not yet seen part 1, you can find the link in the description. Right, first I'm going to assume that you've already put the firmware on, given your call sign and description, and set that as the host name of your node and set your password. And now I will give you a tour of the BroadBand-HamNet node. After that I will show you some footage of a two-way video call that was happening on BroadBand-HamNet between me and Mark 2E0VHC. Once you've set up your node with a name and a password, you can access it by going to localnode:8080 or localnode.local.mesh:8080, and that will bring you up to a page like this. As you can see, this is not my call sign, it's not my computer, this is my friend's computer, as I'm unable to screenshot record from my PC. So if I clear this out of the way, this is my one, and we're accessing it over the tunnel via the internet. So you can see that there's buttons along the top here. Help, you can refresh the screen if you like. You can check out the mesh status by clicking on mesh status, and you will see all the stations that are connected locally and remotely, and all the services that they are offering. OLSR status, that will show you the really advanced routing stuff that is all automatically happening in the background for you. If you're not into routing, you can leave that alone. If you're really into routing or want to see what is going where, go in there, but I advise you not to change anything unless you really know what you're doing. Over here you've got the Wi-Fi scan. You can check out the local Wi-Fi's in the neighborhood of the node, and here you have the setup button. You may have also had a quick brief look at setup when you set up the password and the name of your node, and here we have night mode, which can make your node a lot easier to read and use during night time. Over here you've got the Wi-Fi address. This refers to the RF side of your node. You got the LAN address here, which this is the LAN address of your local node for the devices that connect to it. You've got the WAN address, which is towards the internet, and the IP of the gateway should you have the internet connected. And you've got the number of OLSR restarts and how long it's run for. I did crash my OLSR a few times by being impatient in the OLSR menu, and crashed it just so I could bring this up and show you that. Hopefully you won't see this. Signal, noise and ratio to your nearest neighbouring BroadBand-HamNet node. In this case, this is my other node that is not too far away from the tunnel server. It's 2E0RBT-tunnel client. If I click on auto, it will bring up a bar graph showing the noise level, signal level and the ratio between noise and signal, and this makes it very easy to line up your nodes. And then you've got the setup page here. If I log into my node, you can always get back to the previous screen by clicking on node status, but I'll show you what is in setup. If you change anything down here, you'll need to hit on save changes afterwards, and if it tells you you need to reboot, that button is here. That applies to everything except for down here. If you change any of the settings here, you must hit apply here before save changes, wait and then reboot. If we look along the top here, you've got the menu for basic setup. This applies to the Wi-Fi side. if you're just starting out, stick with all the defaults. Use default channel 1, use default channel width 20 megahertz, the default SSID. You're more likely to discover other nodes in the neighborhood if you stick with the defaults. Down here you've got options for your antennas. I'm using an air grid, so I don't have the option of selecting antenna, and I've got my TX power set down to 7 dBm. Because it's indoors, it's not actually on the roof. I have that, and at the moment it seems my mains is off at home and everything's running off the UPS, so it's good that I'm running as low a power as possible. But when I am testing, the furthest node that I've run to from my house is about 450 meters. So in the distance I put a little bit above that, I put 500 meters. Anything you change in here, hit apply first before saving the changes and rebooting. On the LAN, this is local area network. This is referring to the devices that are connected to your BroadBand-HamNet node, whether they are just client devices for exploring the BroadBand-HamNet, or whether they are servers to provide services for the BroadBand-HamNet node. You can have LAN mode, you can have it NAT, much like a home router would, create a network address translation, put you in the 192.168 range and not internet IP addresses. Or you can actually go for what would be like the internet IP addresses of old direct routers, but you can select 1 host, 5 host or 13 host. I have mine set to 13 direct, and each of the devices that I hook up to the LAN port on my BroadBand-HamNet node gets an IP address on the BroadBand-HamNet. We have some information about the IP address, the net mask that's used, and the DHCP server is turned on. Unless you know what you're doing, leave that switched on. On the WAN side, which means wide area network, this refers to your internet connection. This is where you would connect the WAN port of your BroadBand-HamNet node to your home broadband internet router. You leave it on DHCP, leave it with the defaults unless you're experiencing problems. DNS1 and DNS2 defaults are the Google DNS servers, accessible to everyone. I don't believe there's an ISP that does block them, but if there is an ISP that blocks them, you can raise stuff by address, but you cannot raise it by hostname. These would need changing. And mesh gateway. This is an important one. If you want to share your internet access via the WAN port to other BroadBand-HamNet nodes in your neighborhood that are connected via RF, then you would tick this. But if you do not want to share your internet with your neighboring BroadBand-HamNet users, leave this switched off. The WAN port can be connected so that your LAN devices, your computers and servers, can have internet access through the node, but without sharing your internet to other people on the BroadBand-HamNet. You'd also need a WAN connection if you run a tunnel server or a tunnel client. If I go to the port forwarding, DHCP and services page, you can see there's quite a bit of information on this page, and it may look a little bit confusing. I'm not going to start at the top. If I go to here, current DHCP leases, these are the devices that I've hooked up to the LAN ports of the BroadBand-HamNet node, and you can see that they have the host names, the IP address and a MAC address. If you have devices that are just browsing BroadBand-HamNet and not running services, then there's no real reason to click on add. But if you wanted to get the host name right, say you had a piece of software that you was running on that computer, and someone else on the BroadBand-HamNet node needed a host name to connect to, you could click on add. That would then push it up into the DHCP address reservations. Once it's here, you can actually click on default host name that the device might have given itself and change it. Once you've changed it, you can then click on save changes, and after a little while it will say that the changes have been saved. Now that device connected to the LAN port has an actual host name on the BroadBand-HamNet which can be addressed by other users. If you're running servers, this is where you would give your server a host name for other BroadBand-HamNet users to connect to. Think about this wisely. If you've got anything specific, you could give it a host name for that, like BBHN UK-info is a web service that I do. BroadBand-HamNet UK is myself and a few others, is just an initiative to help get people started with BroadBand-HamNet at present. So I've given it a custom host name there. All my other services, like my PC, which can be addressed for, say, video calls by direct IP calling, my BBS, which is broken at the moment, the machine that I do a lot of testing on, this is where I test services, but they do not run 24/7, so I've just got a target machine to test from across the BroadBand-HamNet, the web page that I explained earlier, and 2.0 cam, which is a tablet device which is connected wirelessly to a third-party Wi-Fi access point hooked up to the LAN port of my node. It does mean using a third-party Wi-Fi device, but it also means that I don't have to run a very long cable all the way to the window where the camera is located. Now if I come over to here, advertise services, for the services that I am advertising that I want other BroadBand-HamNet users to see, I type in the name of the device, so I put in my call sign and a description of what it is. So this is 2.0 Road Cam. Put a tick in there if it's a clickable link, and then the header if it's for a browser. If it's a service that shows up in a browser, that would be HTTP. Don't use HTTPS. We are not allowed to use encryption on amateur radio, so no HTTPS connections. Here you'll have a drop down list of either the devices in the DHCP leases or the address reservations, either from down here or from up here. When you click the list, you can see all your devices. I'm going to leave that as is, and they will show up under the mesh status page as services that are running from those servers. I'm going to skip tunnel server. That'll be for another video. I'll do tunnel server and tunnel client. Oh, I've almost forgot port forwarding. If I go down here, port forwarding. Now port forwarding is when you're using 3.5 or 13 hosts direct. Port forwarding refers to servers that you're running on the LAN ports of your node and making them accessible to the WAN port of your node, so that your home network, and if you do the port forwarding from your home internet router to your BroadBand-HamNet node, then these services could also stretch out onto the internet as well. WAN refers to the WAN port on the node. Type refers to the protocol used, TCP or UDP or both. You need the outside port number, and then you select the device that is hooked up to your BroadBand-HamNet node and the port number that that service is running on. You enter all that down here, click on add, it gets put up here. Anytime you make changes, click on save changes and wait a little while, because sometimes the scripts take a while, especially when they're as full as this. If you go over to the administration page, you can see here that you can update the firmware. If you do update the firmware, you can click on choose file and select the file that you downloaded from the broadbandhamnet.org website, and then click on upload. Or another way, which doesn't always work, so check the version numbers to make sure, you can click on refresh, and after a little while the list, it will tell you that a list has been downloaded, and now you can click on this down page, and as you can see, it's not working at the moment. You have package management. You can upload a package, download a package, or remove a package from here. Do not touch this unless you're under instructions to do so from someone who knows more than me. And authorized SSH keys. You can improve the security on your node by using keys. However, if you do use this method, it means that you cannot access the node remotely over an RF connection using the BroadBand-HamNet, because that would be a breach of the license conditions, because it is using encryption. So just be aware of that. So there is the BroadBand-HamNet node and its interface. I'll go to the mesh status page, show you down here the current neighbors. This IP address should be showing up G4 ELM-01. For the life of me, I can't figure out why it's showing up as the IP address. I've looked into it, but I haven't come up successful. However, his node is working properly, it's passing traffic properly, it even shows up in the list correctly. If you see a host name here without DTD link or mid2 in front of it, then that is one of your neighboring BroadBand-HamNet nodes. As you can see, my tunnel server is local to my tunnel client, and again down here you can see it's got the tunnel client connected via the DTD link. The device to device link is used for co-located nodes, so that the two nodes don't have to use RF to relay messages through the connections on one to the connections on another. Instead, they can use the cable. This makes things a lot faster, and the less time two or more co-located nodes are chattering among each other, the more data that they can pass. So using the device to device link will use the cables connected to your nodes to the network switch. Again, this would have to be the 802.1q VLAN switch, because DTD link happens on VLAN 2. If you see mid and a number, these neighbors are tunnel connections, either from a tunnel server to a tunnel client or from tunnel client to a tunnel server. All other stations will show up on the left side of the screen. Over here we've got the local host, which is this very node that we're looking at, and then immediately under that we have a list of all the remote nodes and the services that they're running. There is a long list on the mesh that I am connected to, and we have stations all over the world connected to this mesh. And I'll just show you a quick demonstration. If I click on 2E0 VHC ham chat, this is a chat room that we can use, and this service is actually hosted on the node. It doesn't get used very often, but I have had conversations on this, and they've been slow conversations because we've never both been on there at the same time. There are other services available on here, many web pages and cameras, and found a few more services that I'd like to show you. G4 ELM web, G4 ELM's cluster and central. We have web page here, picture of his cluster and how it's all connected up, and GCM is hosting Radar's web server. So if I load that up, there's an excellent web page here with lots of useful links. Thank you for hosting. And there's so many services. If you see view-view or requires IE, these are hints to your browser. View-view, if you see a minus or an underscore between view-view, that generally means username view, password view. So same here, you see these cameras pop up. If you are running services in the advertised service, set the name so that you include the username and password so others can use it. That's if you want others to use it. So there's lots and lots of services all over the place, and you can host some too. Right, video conference between Mark 2E0 VHC and myself was a little bit hit and miss, but it was workable as long as we gave each other a little bit of patience to counteract the delay. It was actually perfectly workable, and I'll show you the setup that we was using. Mark's PC was plugged into his nano station, and he was using ExpressTalk. He was using this at his end. This is his end. I'm having to borrow his computer to do this. And then that's linked into his Netgear GS105E, which has the VLAN routing for the internet, and he was located in Eastbourne, hooked up to the internet, 7 miles away in Howsham. Connects up to essentially making a connection through the Netgear GS105E at my end to the tunnel server. From then, the visible path goes through the VLAN switch to the Raspberry Pi running 3PBX asterisk, which is the phone server at BBHN UK PBX, back down the switch into my tunnel client, which connects to other people's tunnel servers around the world, is co-located, so it uses the device to device link. Then it goes 2.4 gigs RF, 4 miles to Hurston Zoo, and gets into 2E0 RPT Air Grid 1, which was on a tripod pointing west-southwest. My tripod isn't very tall, so I was standing on the outhouse, which has a flat roof at my parents' place, and I wonder what the neighbours thought of that, but connected up to that was my laptop PC using the same version of ExpressTalk. My laptop had a webcam built in, and Mark's PC had a USB webcam. Right, let's have a look at the network path used. The path went from Mark's PC to his nano station, down the VLAN switch that he uses to feed his node with internet, 9 miles to my tunnel server. It then went through my VLAN switch to the Raspberry Pi running BroadBand-HamNet UK PBX. Then it went through my VLAN switch using the D2D link to 2E0 RPT tunnel client. Then it went 4 miles across RF to 2E0 RPT Air Grid 1, which was connected to my laptop PC, 2E0 RPT PC. And I'll show you the footage of that now.
Oh, 2E0 VHC, 2E0 RPT.
2E0 RPT. Hello there, Mark.
Yeah, hello, got you. You got picture problems again. Doing the same thing with the camera.
Yeah, me too.
Oh, I've got myself back now, I think. There we go.
We've got dodgy webcams.
Yeah, that's what it is, because yeah, it's working alright now, sort of. This is webcams are running around. So, yeah, it's not too bad really, is it?
Okay,
Yeah,
well, yeah, it's working quite well.
yeah, it seems really good at the moment. I like that.
Yeah. Alright mate, I'll say 7-3 for now. Thanks for helping me out with this test. This one might actually make it into the video.
Yeah. Okay then dudes, no problem. 73s, and we'll catch you up, well, catch up with you soon. Bye for now, 2E0 VHC.
Okay, 2E0 VHC, 2E0 RPT signing.